our solar system, there has been an object the size of Manhattan called Atlas 3I passing through. A lot of experts think it's a big comet.
The James Webb Space Telescope just revealed something unexpected about the interstellar visitor racing through our solar system.
The object is anomalous because it comes in the plane of the planets around the sun to within 5 degrees, and the chance of that happening at random is 1 in 500. Moreover, it's very large. It's comparable to the size of Manhattan Island.
These new images of 3I Atlas show an atmosphere completely dominated by carbon dioxide, unlike anything astronomers expected. The truth about this cosmic intruder gets revealed right here, and it's nothing like scientists predicted. An unusual carbon dioxide atmosphere. The James Webb Space Telescope captured its first observations of 3I Atlas on August 6, 2025, using its near-infrared spectrograph instrument. The results were announced on August 25, 2025, and immediately caught the attention of the scientific community worldwide. The imaging revealed something remarkable about this interstellar comet's composition that sets it apart from every other comet ever studied in human history. The telescope detected that 3I Atlas has a coma almost entirely made of carbon dioxide. A coma is the cloud of gas and dust that surrounds a comet's nucleus as it approaches a star and heats up. What makes this finding extraordinary is that solar system comets typically show a mixture of different gases, including water vapor, methane, and ammonia. But this interstellar visitor displays a carbon dioxide-dominated atmosphere. The observations indicate that 3I Atlas contains ices that were exposed to much higher levels of radiation than comets born in our solar system. This suggests the comet either formed very close to the carbon dioxide ice line in its parent star system billions of years ago, or it experienced intense radiation during its journey through interstellar space. The extended carbon dioxide coma stretches out to at least 560,000 kilometers from the nucleus. This massive atmosphere provides scientists with crucial information about the conditions in the alien star system where this comet originated. The composition tells a story of a very different environment than the one that created the comets we know in our solar system. Understanding this unique chemistry helps researchers piece together how planetary systems form around distant stars. What makes this comet different? Unlike comets that formed in our solar system, 3I Atlas appears to have originated in a very different stellar environment. The carbon dioxide-rich composition suggests it formed in conditions where this particular ice could condense and remain stable over billions of years. Solar system comets typically show much more variety in their composition, with water ice, methane, ammonia, and other compounds mixed together in different proportions. The radiation history of 3I Atlas also differs significantly from local comets. The high carbon dioxide content indicates exposure to intense radiation levels that would have vaporized other volatile materials over billions of years of travel through interstellar space. This process left behind the more resistant carbon dioxide ice that dominates the coma today. The journey through the galaxy exposed the comet to cosmic rays and radiation from various sources that gradually altered its surface composition. Ground-based telescopes with aperture diameters of at least 8 to 11 centimeters have successfully imaged 3I Atlas, though it remains extremely faint even through larger instruments. During its approach to Mars on October 3, 2025, the comet had a total magnitude of 12, making it about 120 times fainter than another comet visible at the same time. This faintness makes detailed study challenging, which is why observations from powerful space telescopes like James Webb and Hubble are essential. Amateur astronomers with modest equipment have also contributed observations, adding to the global effort to study this rare visitor. Recent brightening before perihelion. As 3I Atlas approached its closest point to the Sun, astronomers observed a dramatic increase in brightness that exceeded predictions. The comet passed perihelion on October 29, 2025, at which point it was on the opposite side of the Sun from Earth, making ground-based observations extremely difficult. During this critical period, space-based instruments provided the only views of the rapidly evolving comet. Between September and October 2025, observations from multiple spacecraft showed the comet brightening much faster than expected based on previous models. The brightness increased following a steep curve as the distance to the Sun decreased. This rapid brightening indicated that outgassing from the nucleus was accelerating as solar heating intensified and more ice sublimated into gas. The rate of change surprised researchers who had been tracking the comet's behavior for months. The observations during this period came from several space-based instruments that could track the comet while it was too close to the Sun for ground-based telescopes to observe safely. These spacecraft bridged a critical gap in observations during a key phase of the comet's evolution. The data helped astronomers understand how interstellar comets respond to the intense heat of a close solar approach, revealing important differences from solar system comets. Multiple telescopes track the journey. The Hubble Space Telescope joined the observation campaign on July 21, 2025, capturing detailed images that revealed the structure of the coma in high definition. These observations allowed astronomers to constrain the nucleus diameter to less than 9 kilometers, giving scientists a better understanding of the comet's size. NASA and the European Space Agency released these images on August 7, 2025, providing the first close look at the interstellar visitor. In November 2025, Hubble performed ultraviolet spectroscopy on 3I Atlas to analyze the composition of its gas emissions and measure the sulfur-to-oxygen ratio. The telescope continues monitoring the comet as it travels outward from the solar system. The James Webb Space Telescope is scheduled to make additional observations of 3I Atlas in December 2025. After the comet passes its closest point to the Sun, the Psyche spacecraft, currently traveling through space toward its destination asteroid, also captured images of 3I Atlas on September 8th and 9th, 2025. During these observations, the comet was approximately 85 million kilometers from the spacecraft. The multispectral imager instrument on Psyche provided additional data about the faint coma surrounding the nucleus. NASA released these new images from Psyche on December 3, 2025, adding more pieces to the puzzle. The Very Large Telescope in Chile captured images in July and August 2025 that showed dramatic changes in the coma shape over time. These observations revealed a prominent plume facing the Sun, visible in all the images. During August 2025, astronomers noticed that 3I Atlas began developing an anti-solar tail pointing away from the Sun, a typical feature of active comets. The Gemini South Telescope photographed the comet on August 27, 2025, providing additional confirmation of this tail structure, the fastest visitor ever recorded. 3I Atlas holds the record for the highest velocity ever measured for any object visiting our solar system. When astronomers first spotted it on July 1, 2025, using a survey telescope in Rio Hurtado, Chile, the comet was traveling at approximately 220,000 kilometers per hour. This incredible speed provides definitive proof that the object originated from outside our solar system. The orbit of 3I Atlas is the most dynamically extreme trajectory ever recorded in the solar system. Researchers explain that the comet has been traveling through space for billions of years, gaining momentum from a gravitational slingshot effect as it whips past stars and nebulas. Each close encounter with a massive object in space accelerated the comet further, building up to the tremendous velocity observed today. The path it follows is hyperbolic, meaning it will never orbit the Sun and will continue traveling into deep space after this brief visit. Upcoming close approach to Earth. Following its passage around the Sun, 3I Atlas is now making its way back into the night sky, where ground-based telescopes can observe it again under favorable conditions. The comet is approaching Earth and will make its closest pass on December 19, 2025. This upcoming flyby provides astronomers with a valuable opportunity to study an interstellar object in greater detail than ever before. Observatories around the world are preparing their instruments to capture as much data as possible during this rare event. The Psyche spacecraft remains about 676 million kilometers from Earth as it continues its journey toward the asteroid that shares its name. The spacecraft will fly close to Mars in May 2026 for a gravity assist maneuver before reaching its target asteroid in July 2029. Meanwhile, Hubble will continue monitoring 3I Atlas as the comet heads back into interstellar space after its brief visit to our cosmic neighborhood. Ground-based observatories are now able to characterize the comet in far greater detail as it moves away from the Sun's glare and becomes visible in dark night skies throughout November and December 2025. The December observations will provide the last detailed views before 3I Atlas fades from sight forever, continuing its billion-year journey through the galaxy. Let us know what you think in the comments below, and do not forget to subscribe so you do not miss any new videos. Thanks for watching.